Okay, Michael, thank you for joining me. As I said last time, this time I'm going to, since we've covered, some of the basic principles of hylomorphism, I'm going to contrast hylomorphism with sort of the default philosophy of nature that we tend to resort to, which is, mechanicism or reductionism, that sort of thing. Before we do that, there are a couple of concepts I want to sort of highlight that are not frequently talked about. One is the concept of unity, the unity of being. In hylomorphic philosophy, or in Aristotelian Thomistic metaphysics, things are one. They're one being, and so the concept of unity is quite important. This is a diagram that illustrates the different categories of unity, or the different the division of unity, if you will. Just roughly, there's unity can be unity of simplicity or unity of composition. So things that are completely simple, not composed of anything, have unity by virtue of that. I'm not going to get into this. This has to do with theology. It has to do with the concept of divine simplicity, which is sort of a perennial controversy in theological circles. But for what we're concerned about, the unity of composition, there's a distinction between substantial unity, so substances that we've talked about are one, right? Versus accidental unity, because you can have the unity of the accident to the subject, right? If you have a subject has accidents, the ball is red, or I'm 6 foot, or 5 foot tall, or whatever, so my accident is intrinsically connected to the subject. So there's, but it's an accidental unity because the accident may change, right? I may be pale, I may turn red, that sort of thing. And then there are extrinsic unities, which here can be divided, as an extrinsic unity of purpose. So we talk about one team, right? One team. It's a team. It's one thing by virtue of the purpose that binds together all the team members, right? And so that's a sort of extrinsic unity. And there's also the unity of juxtaposition. You can have a pile of sand, right? It's one pile by virtue of just the juxtaposition of all these individual units of sands. And those would be also examples of accidental unity, right? You can take out grains of sands, you still have a pile, that sort of thing. Modern philosophers like to talk about these. I think nowadays it's termed, piles of sands are termed vague concepts. The ancient Greeks actually played with that also, in what used to be called the Sorites problem, that sort of thing. But anyway, the bottom line here is that the substantial unity that we have in natural things, natural substances, comes from the substantial form. The substantial form is the principle of unity in substances, right? The armadillo is one thing, one being, by virtue of the substantial form of armadillo. Okay, so that's one point I wanted to bring up here. And then another thing that gets discussed in hylomorphic philosophy is the distinction between natural substances or substances in general and artifacts. Okay, so a house, a wall, or a well are all artifacts. They're sort of put together by an external agent, in this case by man, right? An artifact doesn't have to be always created by man. You can think of a beaver building a dam, right? So the dam is an artifact, but it's not a man-made artifact. So the point here is that in those artifacts, let's imagine for simplicity that they're all made of bricks only. Okay, so each artifact is really depends on the arrangement of the bricks, right? So you arrange the bricks in one way, you get a house. You arrange the bricks in a different way, you get a brick wall. You arrange the bricks in a third way, you get a brick well, right? And these essentially, so artifacts are accidental arrangements of the parts, right? and the artifact does not have a substantial unity the way a substance has, right? So an artifact, and that's one of the distinction between substances and artifacts, and we'll get into this more in, you know, perhaps in a different lesson. But the relationship between the part and the whole in an artifact is distinct, because in an artifact the whole really comes out from the arrangement of the parts. Okay. And also in a certain way, the accidents, for example, if the brick is red, then you get a red house, right? It's from whatever accident is on the part that gets transmitted, you know, to the whole. Okay. So that's the concept of the artifact. And the artifacts, as I mentioned, require an external agent, right? That from the outside assembles the parts and puts them together into the artifact. Okay, and in a way, the artifact exists first, you know, in the mind of the external agent, right? You know, I mean, the bricklayer is going to decide how to construct the, you know, what to do with the bricks and make them into a house or a wall or etc. Okay, so I wanted to bring up these two concepts, you know, at the outset before talking about reductionism versus hylomorphism, because that will play a part. Okay, examples of artifacts. Okay, let's move on. All right. Democritus, the father of atomism, is, you know, we credit him as being the father of atomism. And, you know, essentially he is a reductionist. As we will see, I can have a lesson on the pre-Socratics in general, but here, for the purpose of this lesson, Democritus was really trying to answer Parmenides and the followers of Parmenides. So Democritus is answering primarily Zeno of Elea. So Zeno was a follower of Parmenides, and if you recall, Parmenides was the one who said that changes is an illusion, right? Changes cannot be, because nothing can, you know, no being can come from non-being, right? And therefore change does not exist, and therefore change is an illusion. And in his school, he had followers, one of whom was Zeno, and Zeno was very clever. And you're probably familiar with the Zeno's paradoxes, right? So the famous paradox is you cannot cross, you know, the room, because before you cross the room, you have to get to the halfway point. Before you get to the halfway point of that, you have to get to the halfway point between where you are and and that halfway point, and so forth. And to infinity, there's always a halfway point to cross, which means that motion is an illusion, right? You can never cross the halfway point, that sort of thing. He had other clever paradoxes, you know, Achilles and the tortoise, and the motion of the arrow. The motion of the arrow is an illusion, because the arrow is either moving or not moving. You know, if it's moving and in one place at the same time, that sort of thing. Again, in a separate lesson, I can go into Zeno's paradoxes in more detail. But Zeno also, you know, the question was, if you take a body, a solid body, and you divide it, you know, according to Zeno, you could divide and keep on dividing and keep on dividing to infinity, and therefore never get, you know, any place from those division. Democritus asserted that no, that can't be. I mean, so Democritus was trying to defend our sense that there is change in the world, right? That we can move from place A to place B, okay? And therefore he thought that, no, if you take some solid matter and cut it and cut it and keep on cutting it, at some point you're going to get to uncuttables, atoms. Atoms meaning, you know, not cuttable. Tome is to cut, and atome is to not cut. So that was the answer to Zeno's paradox from the pluralist and from Democritus in particular. That so matter must be composed at some point deep down of uncuttable things. Okay, and in between those uncuttable things is the void. Okay, and therefore motion has to do with a rearrangement of movement of atoms in the void. And the reality as we experience it is essentially void, atoms, and their motions. Okay, and the beings that we see, a cat, a dog, a giraffe, a human being, different atoms getting together or getting rearranged in certain ways. Okay, it's unclear exactly what was the cause of the motion. It was in those days it was perhaps poetic. People, they talked about the vortex, or another pluralist would talk about primordial forces, if you will, love and strife being opposing forces of assembly and disassembly of these unchanging basic elements called atoms. Okay, but basically the whole thing, the whole motion, our perception of reality, that things are changing and interchanging and changing from one thing to the next and so forth, is fundamentally a change in motion of unchanging things. Okay, so again, in Democritus, and Aristotle comes later to refute Democritus, there's no concept of potency and act, or in a way, if you will, the atoms are actual, right? And there's no potency. I mean, but the bottom line is that they're unchanging. A famous saying by Democritus is this: that's one of the few fragments that survive. This particular one: by convention sweet, by convention bitter, by convention hot, by convention cold, by convention color, but in reality, atoms and void. Okay, so for Democritus, the fundamental reality are the atoms and the void, which, in a way, doesn't solve, I mean, it only solves partially the problem of Parmenides. I mean, Parmenides said there's no change whatsoever. Democritus is trying to explain change, but then we don't really have access to the fundamental reality, because what we perceive is sort of an illusion, right? The taste and the hot and the coldness and the color, all of that is what we perceive. It's in our mind, but fundamentally is just atoms in the void, atoms swirling in the void, and the atoms are unchanging. And it has to do with the rearrangement. So what were, the atoms, according to Democritus, or the people who've studied Democritus, so he postulated an infinity of atoms, right? To explain this vast diversity of things, he postulated an infinity of them. Each atom had different shapes, and also each atom, possibly by having a different shape, had a different propensity to bind to other or to interact with other atoms. All of this is kind of sort of vaguely treated. But the bottom line is that the atom is unchanging. There's an unchanging reality, and and here I will use the Aristotelian term, accidental rearrangement of these unchanging things that gives us the diversity of beings that we see. And Aristotle had a problem with that on a number of points. First of all, the void is again non-being, and so it's for Aristotle it's inconceivable, and in a way it's not really a response to Parmenides that Democritus provided by postulating the void. Democritus gives the void an ontological reality equal to the atom, right? They're both as equally existing. The void exists, right? Which is, for Aristotle, it's a contradiction in term to say the void exists, because by definition, the void is non-being. Democritus postulated an infinity of unchanging things, which for Aristotle is a problem in reality. In our finite world, to resort to an infinity of things is not tenable. Again, I'm not getting into the details of the refutation here, but the main one that that we've covered is that in Democritus's scheme, there's no real distinction between substantial change and accidental change. Everything is essentially an accidental change, right? And there's a blurriness. And then, so if there is a distinction, somehow it must be in our mind. and therefore our mind becomes even separate, because our mind would be separate from the atoms and the void, right? There would have to be a mind observing the artificial reality of things. So that's Democritus. And Democritus, for a long period in antiquity, was very dominant, because when Aristotle died and when his school waned in importance, you had other philosophical schools that were, the Epicureans, the Stoics, and so forth. All of them were pretty much, even though they were not so much concerned about natural philosophy, they were primarily concerned about ethics and, living the good life and so forth. Nevertheless, they accepted the proposals by Democritus that reality is material made up of unchanging things, and it's just a constant rearrangement of these atoms. And then there's in the medieval period, there in the Muslim world and in the Christian world, there's a renewed interest in Aristotelian philosophy. Aristotle becomes dominant until the end of the medieval period, and until the beginning of the modern period. And the modernists, for the most part, were atomists in some form or another. Okay, and I'll take Descartes as an example. Descartes, again, his physics was predicated on there being corpuscles. So he didn't use the term atoms; he used the term corpuscles. Little things that are unchanging, but are assembled and reassembled. The difference in the modern period is now you have the laws of motion, right? So you have the mathematics. Starting with Galileo, you can start quantifying the motion and making predictions about the motions of beings, and so the reductionist atomism becomes quantifiable. Okay, and of course it becomes very successful in a certain way. Mechanism, which in a way is mechanism or mechanicism is distinct from reductionism, but they're sort of interrelated. Newton, if you will, was a mechanicist. He was not. There's nothing in Newtonian philosophy, in Newtonian natural philosophy or physics, that talks about atomism necessarily. But to the extent that perhaps Newton thought about matter as being composed of little planets, if you will, he was preoccupied with the big planets, the big stuff around us, the big motions of the bodies. The idea was that if atoms existed, they also would follow mechanical laws, right? The mechanical laws of motion. And so mechanicism emerges in the 17th century, becomes very successful. We have the scientific revolution that proceeds apace, and its ability to predict physical phenomena is astonishing, and it gives rise to a wonderful technology. But in this whole scheme of things, there's always underlying the notion that whatever whole we're talking about is essentially emerging from the parts. Okay, so the relationship between the parts and the whole in reductionism is that the parts give rise to the whole. Okay, perhaps another way of framing it would be to frame it in this way. Reductionism, the whole is in the arrangement of the parts, meaning their position and motion. Okay, so you have position and motion, and from that, then you get the whole. If you understand the position and the motion of each part, then you understand the whole. What's interesting and perhaps poorly appreciated. Oh, here I have, before we go further, I have this quote from Carl Sagan. I am a collection of water, calcium, organic molecules called Carl Sagan. I mean, so that would be sort of the poster child slogan for reductionism. Okay, the parts explain the whole. So Carl Sagan himself is explained by the arrangements of water, calcium, and organic molecules. What is pretty appreciated is that the reductionism of Carl Sagan is not very different materially from the mechanicism of a theist like Paley, okay, who thought of, who had his watchmaker analogy, and he said that, he was trying to invoke a god as the cause of the universe, on the basis of the complexity of the beings, being arranged. And he said, if you were to stumble upon a watch, walking along the forest, clearly you would say, oh, there has to be a watchmaker responsible for this assembly of parts into a watch. Okay, and so the main distinction between a Carl Sagan and a William Paley is who is the, who is there a watchmaker, a conscious being who's a watchmaker, or is the watch assembled randomly? Okay, but in both cases, the notion of artifact, I'm going to use the artifact, is there, right? So for Paley, the world is an artifact assembled, by God, right? Which would not be the case for Carl Sagan. But the understanding is to understand the material world as an artifact. Descartes, similarly. So Descartes was, if you read the theology of Descartes, he thought for sure that his corpuscles in motion, the laws of motion were provided by God, and so forth. So the mechanicism of Descartes was a theological mechanicism, if you will. Our modern day mechanicism, if it, should it be atheistic, is nevertheless is also a mechanicism. Okay, and the common point is that nature is viewed as an artifact, as artifactual. Okay, which is unlike the hylomorphic philosophy. So present day hylomorphists don't think much of intelligent design arguments, if you will, right? Because the intelligent design arguments are predicated on this idea that the natural substances are artifacts, are mechanical things that are assembled together, that the parts eventually explain the whole. So the intelligent design argument is that it's too complicated to rely on randomness to explain the parts, but they still buy into the idea that the whole is caused by the arrangement of the parts. Okay, so in hylomorphism, that's not the case. Now, there's been a backlash against reductionism in the last 100 years. Okay, number one is the discovery of the subatomic realm, right? So if in the 19th century we could people could postulate and design chemical experiments that seem to lend credence to the idea that there are atoms, but it turns out that the atoms that were, the term atom as currently or by modern physics as it is attached to certain things, those atoms are still cuttable. They're not uncuttable, right? So an atom seems to be divided by other things that we seem to have a very hard time talking about. But it's certainly not the same idea. It's not your grandfather's atomism. It's not Democritus's atomism. It's not Descartes' atomism. Because, when we go into the subatomic realm, it's hard to isolate the position from the motion and whatnot. And it becomes very difficult to, we have to concede that the original model of unchanging, a fundamental unchanging reality, whose rearrangement explains the whole, doesn't seem to be holding, and we don't have currently, a language to talk about this. But certainly it's a setback to the mechanicism, if you will. The discovery of the subatomic particles and all the uncertainties associated with them are a little bit of a setback to the old model. And then, more importantly, the part-whole problem that modern philosophers of science have highlighted is also a little bit of a backlash against reductionism. And the part-whole problem really has to do with, can you really explain a whole on the basis of the parts? And that's been primarily talked about in relationship to biological phenomena. Okay, so you have a human body, lots of parts. Can you really explain the whole of the body on the basis of the parts? Okay, and here I'm gonna use to illustrate that. I'm gonna use a very, very simple example. I'm gonna even simplify it over this diagram. Imagine you have a bacteria, and imagine a bacterium, a single bacterium, a single cell organism. And let's imagine, for the sake of simplicity, that this single cell organism is simply a lipid membrane, a fat membrane on the outside, water inside, and some proteins. Okay? It's very hard on the basis of reductionism to explain the whole as a whole, and to explain the whole as simply an assembly of the parts, because the parts don't seem to be behaving as part. And I'll give you an example. And again, it's a simplification. I don't want to spend too much time in this lesson about that. But let's say, because you say, well, water, according to the laws of physics, should not mix with a lipid in that way. Normally, they according to the laws of physics, the reductionist laws, they should be kept separate. Whereas here, it's enclosed by the lipids. Well, then the mechanicist might come back and say, well, no, because the reason the water is staying inside, right, and not leaving the lipids, is because the lipid is held together by the proteins in this particular configuration of being like a sac. But then you'll say, well, okay, fine, but what's keeping the proteins in this particular way? And the only way the proteins are in this particular way is because they are in water, right? Because if they were not in water, they would have a different configuration. And therefore, so you go back, you have essentially a circle that it's hard to get out of, okay, to explain the arrangements of the parts into this persistent whole primarily on the basis of mechanistic reductionism. Now, of course, my explanation here is not completely foolproof. People say maybe it could happen. It could happen by chance that all these pieces are sort of put together so exquisitely by chance that it so happened that you can have an organism like a simple bacterium with a lipid panel and a lipid membrane and proteins and water inside. But the question of chance, that if we accept the emergence of if we're going to chance could explain the appearance of this artifact as one thing, right? But it's hard to explain the maintenance of this artifact as sort of over time and its reproduction, that sort of thing. Again, this requires a bigger treatment, but I just want to sketch the broad outlines of the difficulty with reductionism, to explain if reductionism is going to be explaining the whole on the basis of parts. There's a problem, at least as far as biology is concerned, right? And that has gotten a fairly well-respected that point of view that reductionism is faulty has gotten a fairly well-respected place in academia nowadays. Okay, so if for a while the mechanicists were predominant, now many of them are conceding that there's a limitation to reductionism. Okay. So hylomorphism is distinct because in hylomorphism we would not consider a being like a bacterium or a gazelle or a human being or whatnot as an artifact. All these beings have a substantial form, right? And the substantial form is the principle of unity. And the substantial form, as we talked about last time, actualizes and informs the whole, and it actualizes and informs each part of the whole. Okay, so we have a principle of explanation for the entire being, okay, which is the substantial form, and we make a distinction between a substance and an artifact. Okay, whereas the artifact is an accidental rearrangement, the substance no is a substantial being. Okay, it has its own substances. And we did that even before. So our concept of substantial form did not start by examining part and whole relationship. It started by trying to explain change, right? The reality of change. And it had as its starting point the fact that we, the law of identity, that we see that the world is made of distinct beings, right? And that there's a substantial distinction between, say, a living organism and a dead organism, that sort of thing. Okay, but it so happens that the substantial form also explains the unity of substances. Okay, now of course, before we talk about emergence, I want to talk about we haven't covered this, but hylomorphism recognizes what Carl Sagan alludes to, that complex beings like a cow and whatnot is made of simpler elements, okay, that have a different nature, right? So the cow is made of calcium, and in a certain sense, the cow is made of calcium and organic elements and water and whatnot, okay? Later on, we'll go into the hylomorphic elemental theory, right? So how does hylomorphism explain this, the truth that beings like a cow are made of elements, right? But nevertheless, hold on to the fact that the cow itself is its own substance, right? And therefore that the elements exist in the cow in a certain way, okay? And that's the fundamental, the fundamental aspect of hylomorphic elemental theory, is that the elements that are in the cow or in the complex being, their ontology changes. Okay, their ontology changes. They retain some of their elemental properties that they had when they're outside the complex being, when the elements are on their own. They retain some of their elemental properties, but in essence, their properties change because now they're under the rules, so to speak, of the substantial form of the being. Okay, so in a subsequent lesson, we'll talk about elemental theory, which to me is the most critical portion of hylomorphism to develop and to gel with the findings of modern science, to be able to justify hylomorphism as a respectable philosophy of nature, if you will, is to really articulate the elemental theory very, very well. But the bottom line is that hylomorphism has a way to explain the unity of beings, the unity of substances, in a way that reductionism does not. And then I have one more slide to talk about emergence theory, which emergence theory has been essentially a modern response, the last 60, 70, 80 years, a response to the backlash against reductionism, right? The failings of reductionism to explain wholes on the basis of parts. There are now what's called emergence, many different kinds of emergence theories, which, hylomorphism or hylomorphists look favorably upon, right? And they say, okay, yes, you're right to highlight the fact that reductionism is flawed. But so far as I can tell, emergence theories are still not very cohesive and not well articulated. They essentially posit that at some point, when you have a certain amount of complexity, that the whatever governs the state of affairs at the lower level, no longer applies, and you have to, new properties emerge, right? So if you have a bacterium, okay, you have water and you have proteins and whatnot that, on their own follows the laws of physics. The reductionism works at the level of the parts. And then when the thing is somehow assembled into a whole, then you have emergence of new properties, okay? And the criticism that the hylomorphists would have against the emergentist is that because they don't articulate, what's the relationship between the elements and the complex systems and whatnot, it frequently would essentially tend to collapse back into reductionism. Okay, or you know, I mean, it's not yet, you know, as of yet, they don't offer a coherent means to pass between what they would deem simple systems that follow the reductionist laws of physics and more complex systems that do not. Okay, so that's my little spiel for this lesson, to start to give an idea of, you know, why are these principles that we've talked about so far, prime matter and substantial form, you know, in practice, how does it make the philosophy of nature different from what we've what the alternatives are. Okay. And any questions, or we can take a break and we can do a Q&A session after the break. It's up to you.
I don't think I have questions. This lecture was put some meat on the bones of the earlier ones.
Right. Yeah, I imagine. And, you know, and I thought maybe I should even introduce the whole topic with, I might, you know, if I have an introductory video, I might have an introductory video, maybe distill this into a 5-minute thing where I can just, you know, quickly highlight what the project of hylomorphism is really to try to resolve this tension between, you know, reductionism and the fact that, you know, there seems to be things that reductionism cannot explain, right? Between the success of reductionism, in that, in a way, reductionism has been very successful in its predictions, in its you know, analytical power and so forth, but it seems to be lacking in its explanatory power. I just want to say briefly here that mechanicism is actually Aristotle makes mention of mechanicism. And he says that mechanicism is perfectly correct so long as you're looking at the part of a thing. If you're looking at a part of a substance, then mechanism applies. And you can look at it as an artifact. So long as you look at it as, you know, look at the part of a substance, you can conceive of it as an artifact. And so that's the way that hylomorphism actually acknowledges the contribution of this reductionist approach. Okay, it's a technique to try to shed light, but it sheds light only on the parts of things. Okay, and it can consider them as artifacts, and that's why, so long as we keep in mind that it's not the whole story, right, and that the whole story requires its own explanatory principles. That would be the hylomorphic principles. Okay, very good. So we'll stop here, and then the next time around, I may be bold enough and start to talk about the elemental theory, hylomorphic elemental theory, and it requires some boldness because you know, the elements for Aristotle were air, water, fire, and earth, and so and so we need to understand how that gels with what we now know about the world. All right, but thank you for joining me, Michael.
Okay, thank you.
I'm going to stop the recording here.